we'll do another hands-on project again that's based on the LSTM only, just to get the idea about how the LSTM works. And even I want to bring the various types of LSTM into picture, right? So that we can use it for the main project, which is right, the price prediction of houses, right? Okay, right. So before that, we have our next one. Yeah. So this is again a prediction case. Okay, prediction code, and here we are going to predict another time series. We'll try to predict the stock exchange, right, data. All right. So again, that's a very useful, very insightful. We'll get a lot of things to learn here. All right. Let me create. Okay, let me create a folder. Okay, this is again LSTM. Stock market. So inside this, I'll open a new this thing. So first we'll write a function, right? I'll teach you how to simulate the stock market first. Let's not directly go to the stock market and get the data and let's working on that. That's right. Anyway, uh, that's actually a real time this thing. But what I want to do, I want to teach how do you simulate the stock market, right? This is a new thing which you can study. All right. So for that reason, right now I'm not downloading the stock market data set directly into my machine and running that. Instead of that, I would like to use a standard equation and simulate that, right? I'll teach you how to do that. Okay, right. So let's write a function that simulates the stock market. So I'll call it by the name stock stock prices. Okay, let's open up that. So it opens a new this thing, and now, so there is a standard equation that tries to simulate the stock market data. Okay, so I'll try to write that. Okay. Okay, so there is an equation called the ds by dt is equal to r plus sigma times d omega of t by dt into s, right? This is the actual equation, right? That represents the stock data. ds by dt is the rate of change in the stock, right? This equation is the one which represents the differential equation format of the stock price. Okay, this is a general one. Now you see where S is the stock price. The omega t is actually a random process. It's called as a Brownian process. It's a mathematical process which represents randomness present in any of the variable. Now we try to model the stock data using the W of t, that's it, or omega t. Actually omega, but in computers we write W of t. Okay, it's a random process, right? And the t is the time. Dt is a small time, like day to day. One day difference can be differentiated like that. Okay, and there are two parameters related to the stock data, right? One is called as a R, that is called as a drift. Okay, in a sense, if you observe the stock market trend, like if it is high at the highest position and if it starts decreasing, that's a trend. Okay, drift, right? Which direction it is moving. And there is another parameter called volatility that is denoted by sigma, right? Both these parameters will vary between 0 to 1. Okay, so we know that we already have studied in mathematics what is a differential equation and how do you solve the differential equation, because as of now I have to solve this differential equation to get the stock right data. right? So I have to solve this equation, then only I'll get the stock data. So the solution looks like this. Okay, again, we have the standard solution for this. So I'll show you that solution as well, right? Actually, in the code, we are going to write this one, which is the solution. Okay, you see ds of t by dt was the actual differential equation. When we use mathematics, right, various methods are available to solve the differential equation. That differential equation, when you solve, you get s of t. Now you see s of t is equal to this s of 0, initial value of your stock, e to the power r minus sigma square by 2 times time t plus sigma times omega t. All right, so this is the equation. Now, anyway, this is the equation that we are going to write a code to model our stock data. Are you okay with this? Right. So I just wanted to start from here, start from basic. That's why I showed you this equation. All right. Now we'll come back to MATLAB, and in MATLAB we try to simulate that. So my first objective here is I need the data, right? As I told, I'm not using the data that is directly taken from the stock market, because I want to teach you how do you simulate something. When you have an equation like this, how do you use that equation in MATLAB to get the data corresponding? Okay, right. So because of that reason, now we'll start the coding part of that. Okay, right. So this is a function. Okay, in my later on we are going to write uh, the LSTM, the neural network, deep neural network code to, right, do the classification or do the prediction, right? Right. In that, I'm going to use this particular code to this particular function to generate the stock prices. All right. So it's going to be a function, right? So the same name, function stock prices. Okay, let me check. I'm supposed to return something, right? So I'll copy this. This is a name, so I'll write it later. Function. Let's try to return two things. One is a stock value and one is a time variable, because at what time, what is the stock price, right? This is what is the stock data, correct? So the overall goal is like, look at the past data of a particular stock and predict what is going to happen in the future. This is what is our main problem statement. Okay, I have all the past data with me, right? Right now I don't have it, I'm simulating that. But normally in a real-time data, you directly download it from the website, right? You get the data set of maybe last 20 years or something is directly available in the this thing. Okay, all right. So S comma T is equal to the stock prices of, let me say what I'm going to pass this. I'm going to pass few variables. Uh, Let me decide what variables I'm supposed to pass first. Okay, I need to pass the initial price. Okay, anyway, I'll write the notations first, then I'll tell you what they are. Okay, so this is S naught is my first thing. I'll pass the initial one, then I'll pass the R value. Okay, then I'm going to pass that sigma, everything you saw in the equation, correct? And I also need the okay, what is the total duration? I'm going to call it as a T end of the time, right? Like maybe 5 years, 10 years, something like that. I want to simulate till that. And how many intervals you want in that? So it is n intervals. Sorry, T and T. N intervals. Okay, so let's say I pass these parameters to this. So S naught is the initial value of the price. R and sigma I defined already. T end is the end, the duration of the time, and N int is for this. Okay, is the number of intervals. Right. Now let me first calculate inside this function. Let me first calculate the variation that is defined as a delta. So delta is equal to what I'm trying to do here, it's the total time divided by the number of intervals. That's what is the small change. Okay, so how do you calculate that? That is t, I think t end. This is t end divided by n interval. That's the delta value. Okay, and then yeah, okay. So let's calculate first delta. Then I'm going to call the delta values. It's called as, there is what is called as a square root of delta. That's s delta. Square root of the delta is equal to, you can use the square root taking function sqrt of delta. Okay, then I will create the time axis, right? So t is equal to, right? You have to start from 0 and go till the end of that. So how do you create? You create a, it's a linear space. If you remember, linspace is the command. Okay, it creates, right, linear space starting from your first number, that is 0, till the last number. What is the last number? Last number will be the t end. It's a time end. You can see the names given to understand that. Okay, so t end starting from the starting from 0 till the t end. How many samples you want, you need to specify. That is number of intervals plus 1, because I need to include even the last number, so I have to. So for example, if you see, I'll just show you the example here, right? I call the linear space of starting from 0 till say 50, and I want say 5 equal intervals between this. You see, it gets divided, right? The 1 to 50 gets divided into 5 different numbers of 1, 13.25, like that. You can define whatever you want. If you change this number, say the last number, if you change it to say 8, 8 equal spacings, right? That's what it is. So I'm creating that such a lean space, and I'm going to put it into the T. Now T is a one-dimensional array. Okay, right. So that's done with the T. So next I'll define a parameter M, that is actually the length of S naught. Okay, so that means M is equal to, it's a length of S naught. S naught actually the initial value of the, what you call, the stock, right? If you have 10 stocks, then there will be 10 S naughts. Okay, so S naught will have 10 different values. I'm trying to find out how many stocks I have. Okay, so that's why I'm doing this. So let me create a W now, because that W process is what? It's the process, random process, which decides the random, which tries to simulate the randomness present in our stock data. So that is what, which is a variable, I'm going to call it as a W. Okay, so W is equal to, let me start with the first, I'll be having some zeros, right? So first let me put that. So this is zeros of so many stock m comma 1, right? M rows 1 column. That's my, you see, that's the first column of the W matrix. And you see, I'm actually trying to take I'm trying to take use another function called sum, cumulative sum. All right, so let's look at the details now. Help cumulative sum. Okay, so you see here, if I try to write a cumulative sum of the elements sum of x, computes the cumulative sum along the first non-singleton dimension of x. All right, so that means, right, let me try to write the cumulative sum of, I'll try to write a vector over here, 1, 2, 3, 4, 5. Okay, just calculate that. So first element only, it actually calculates the sum of all the elements previous to that. Okay, so 1 means it is only 1. So when I write 1 and 2, the sum is 3. That's why the second number is 3, right? The third number, 3 plus 2 plus 1, 6. Then 4 plus 3 plus 2 plus 1, 10. 5 plus 4 plus 3 plus 2 plus 1 is 15, and so on. You can see, right? So that's what the cumulative sum is doing. So I'm going to use that function now over here. Okay, so it's the next, uh, after m rows, one column, the next column will be this one. Okay, that is, I'm going to use cumulative sum of, so one of the variable which we already have defined is s delta. That's the square root of that delta. Okay, s delta, right? I need to multiply, but since there are multiple elements, it's element by element multiplication, right? So what happens now? It's dot star, right? It's not a, if you simply write star, it is a matrix multiplication. Matrix sizes should match. That's a problem that which you face. Now, I don't want that matrix multiplication, right? Instead of that, what I'm trying to do, I'm trying to calculate the element by element wise product or a dot product. Is it okay? So how do you represent that? You represent using this dot star, right? Again, I want to bring the randomness in W of t, right? So in order to bring the randomness of W of t, right, you see I'm going to use a function called RANDN. So if you remember from the basics of MATLAB, where we studied the rand_n function, if you write a number here like 10, it creates, right, 10 into 10 number. It's an random numbers, n standing for normal distribution. Okay, you are creating random numbers of size 10 cross 10 which are normally distributed, in the sense you have, right, positive as well as the negative, right? You can see that, right? So I want my stock data to be of the similar type, because I want to see all of a sudden increase in the stock value, decrease in the value, and so on. Okay, so because of that, I'm using the rand_n function. If you don't want negative, you can still use the rand function. It's just rand of 10. Okay, so there is a difference, right? When you don't use uh, rand_n, and if you say simply rand, still valid, but it is random numbers between 0 and 1. Negatives are excluded. Okay, so that's what is this. So we are not using that rand, we are using rand_n. Okay, so look at the rand_n now. So rand_n is randomly distributed numbers, the normal distribution of random numbers, right? 10 into 10, and all the values between -1 to +1, between that. Okay, all right. So I'm using the rand number, but again, I'm not, I have to match the size, because you see there are how many rows? There are m rows, right? I have to specify the exact this thing now, right? How many rows I want, I need to specify. So that is again possible here. If you try to write, say, random of, right, say 10 comma, if I write a 4, you see what happens, right? 10 rows, 4 columns. Okay, I can do this. So what I do, in order to match the size of my previous this thing, I already mentioned that I need m rows. So this rand_n also, right, into randn of, right, I have to specify how many rows. Rows are already previously defined, that is m. Okay, because you see zeros are created with so many, right, m. That's why I'm writing m here, right? And I need to specify the number of columns, right? That will be comma the number of intervals. Okay, so I try to create the W now. W is a random process. Okay, then now I create the space required for the stock. So this is equal to zeros, right? What should be the size, right? It should be one row. Total, how many samples are there? N interval plus 1. Okay, starting from the first point. So this is n int plus 1. Are you okay? All right. Next, now you see, I'll go back to the equation, and one part of the equation I'll try to represent. Okay, that is, so look at the equation once. So this equation, you can see that there is e to the power r minus half of sigma square into t. That's the first part, right? So in the exponential, I have in the exponential term, I have two parts. One first part is r minus half of sigma square into t. Okay, and the second part is sigma w of t. So w is created already, sigma is defined. So r is what is also defined, right? Now you see what I need to do. I will define the first part of the function, that is r minus half sigma square, as a function f. Okay, that I'll calculate separately and I'll keep it ready first. So this is how I'm going to do that. So I'll define the f. The next one, this is f is equal to, right, it's, if you remember the equation just now I showed, it is r minus, so I need to take the square sigma divided by 2. So that divided by 2 I'll write first, that is 0.5. Okay, it's half into, I know that I have to take a sigma square, correct? So half into, I think we already wrote a sigma. Okay, sigma, what do you want to do? You want to square it, right? So how do you square it? It's a sigma dot power, so dot power 2. So that is the term which we were looking for. Okay, now I calculate this for every m different values. That's all, right? That finishes this function. So I'll use a for loop. Because I know how many, what is the length. That's why it's a fixed. So I'm using this. So for, say, for k is equal to 1 to m, right? There are m different instances, which iterations I need to perform. So s, this is stock of k, it's a kth row, comma, all the columns. Columns are defined already, right? You know the w value, that will decide. Okay, so that's why I'm not writing the number of columns here. This is calculate s naught. S naught has k different values, k different stocks are there, so there are k different values. It's s naught of k, right? I'll show you the equation once again for your reference. This is what we are going to do now. So you see s of t I'm calculating s naught into e to the power something, correct? Out of that, e to the power first function is calculated, f is there ready. F into t plus sigma into w of t. This is what I need to do now. Okay, s of t is equal to s naught e to the power f into t, because f is calculated, f is equal to r minus 0.5 sigma square, just now calculated, right? So that you use, multiply by t plus sigma into w. Okay, let's do that. So this, now I have k different elements, right? So I'll move back to the MATLAB window. Okay, I know that I have k different elements in S naught, so I need to multiply. This should be multiplied by, so into, what is that? Exponential. E to the power is exp in MATLAB. Okay, exp of the first I need to f, right? F is going to have many values, right? F is going to have many different values, right? Because we defined them in the same way. All right, so f, this is exp, let's write f of k, multiply that with the t, because t is not written yet, so f into t, then you see plus the sigma value again sigma of k, right? Multiply that with into the w function. Anyway, w of there is no t now, w of k, because k is the instant, k comma all the columns. So that calculates this. So let's try to end. Okay. All right. Now, uh, let's do one thing. Let me save this and let me check whether this is going to run or not. Right. So let's just verify. Let's put some values in the command window and let's try to check that whether it's going to run first. Okay. All right. So what are the values you need? You need S naught, you need R. Okay. Let me write, say, S naught is equal to, so say 8256.28 maybe. Okay, that is S naught. Then I want to define what is R. I know that R is between 0 to 1, so 0.1656899 some number. Okay, all right, that is R. Then let us define the next variable that we want to pass is a sigma. Okay, so sigma is equal to 0. Maybe 19. Okay, fine, that is defined. Now then I need to define the t end is equal to, say, 4.25 maybe. It's years. Okay, and let me define the number of samples I want. Say n is equal to, so if I consider I need to write the maybe number of days in which you want to take the samples of the stock market. Okay, so maybe I'll try to create it something like so in 4 years we will be having, let's do a maths. Okay, if you have a calculator, do this calculation. So there are 365 days, okay, into 4.25. So that is 1551, 1552. Anyway, right now I'm not neglecting the Saturday, Sundays. Okay, so I'm keeping Saturday, Sunday. So 1552 is what I'm going to write here. So in the sense, I'm trying to simulate the stock, right, for 1552 days, 4.25 years. Okay, so right, again, this is a simulation, right? So I'm trying to generate my stock data. Okay, so call the function that is S comma T is equal to, call the same thing, stock prices of this. Oh, n int is it's just n, I guess, because I defined only n over there, not n int. Okay, let's see. Yeah, so all this has been created now. Okay, I didn't give a semicolon. Because of that, it's showing everything. Let's put a semicolon. Okay, now you see the S and T have been created here, right? S and T. Now, just to visualize, I'll go for a plot. Okay, the time axis comes first, T comma S. Can you see the plot? The stock plot? I think only half coming. Just hold on. I'll just try to bring that. You see, we created a stock price, right? Stock is increasing, right? The out of the three, whatever, sorry, 1550 days, you started from somewhere smaller value of the stock, right? It was here, as you can see, as you increase, right, it's increase. You can see the value also. You can click over there and you can, it will show you the value, right? So X is like, okay, actually I can, it's a number of years, right? So after 1 year, exactly 1 year, you can see this was the price somewhere 1.01. Can move it, so just to make it right, 1 year 12,263. So move away 1.96, maybe somewhere close to 2. Is it possible to come to the 2? Yeah, very close to 2 means maybe this one. Next one, 2.09. It says 15,000 something. You see stock market, right? So increasing, decreasing happening, right? Okay, yeah. So that code is working now, right? We try to generate the stock price, right, for any defined amount of time, right? So means you can generate 20 years of data, absolutely fine. You can generate 10 years of data, 30 years of data, whatever, right? So again, my intention here is to show you how to, if you have an equation with you, how to write that equation in MATLAB to generate the, to simulate that equation, right? Again, this here we are using only one equation, but when you go for a very complex process, right, you may have to use many equations. You get a s of k from various parameters, use that s of k in some other equations that again may be a solution of a differential equation, and so on, right? You can do this, right? That's showing that is my objective, because these kind of complex we never studied when we discussed the fundamentals of MATLAB, because our intention was not to do mathematics over there. We just wanted to look at the basic concepts of MATLAB. Okay, right. So this was one concept which I wanted to teach. That's why I took, I didn't take the stock data directly from the stock market. We try to simulate. Okay, right. So depending upon, if you know the initial value of some stock, right, you can go to the stock market, check a, take a specific what you call stock, all right, identify its value 10 years ago. Okay, identify what was the value of that stock 10 years ago. Okay, right, put that value here, right? So that means what you are supposed to do is, uh, from the stock market you need to extract these data, right? So this will be your initial value, okay, of a specific stock, right? Identify specific to the exchange, right? You need to identify what is R and sigma. Normally this will be smaller values, closer to zero point 0.1, zero point 0.2 or something, okay, normally, right? So if you take a 10-year-old data of a specific stock, right, that will be coming here, okay, as S naught value. Then identify which stock market it is it Indian or any foreign currency, etc. Right? Check that. What are the R and sigma values corresponding to that stock? Put this as 10 years. Calculate the number of days in 10 years and put it over here. Okay. And call this function. This should return your today's approximately a trend corresponding to that stock. That's all. I'm not saying it will be exactly same, but you will see some trend. Okay. So it means whatever code we have written, right, is trying to simulate that equation, which is the equation governing the stock market variations that we had. I already shown you earlier, right, that s of t is equal to s naught into e to the power something, that particular function, right? It actually tries to simulate that. That's the closest stock market approximation, right? Okay, all right. So this is the first function which right now, right, this is just a price, right? Now my next intention before I write the actual code is to write a function to plot, right? I will plot my function once again. Okay, I might have to plot it, so let's go for a new function where I plot it. Okay, so let me write edit plot stocks. I'll write another function to okay. Now I'll pass a few things to this. Right. So that is that's right function. I'm not returning anything. I'm directly plotting it. So nothing to return directly. When you don't have any return value, you can directly call the plot the stocks. Okay, plot stocks of, right. I will pass the time. I'll pass the stock price. I'll pass what is called as a symbol. These things I'll pass. Okay, now let's see how do we start with. So let's calculate the number of stocks once again. So M is equal to, inside this I need to calculate that is size of S comma 1. It's a number of rows. It gives you the total number of stocks present over. Okay, now if you remember in the basics of MATLAB class, we have one function to define the different variables of the plot, right? Variables such as what should be the X label, what should be the Y label, okay, what should be the title of the figure, etc. We can specify directly, correct? So directly we can define in a single command instead of writing different commands for X label equal to this, Y label equal to this, etc. Right? I can write a single command, right? So that command, if you remember, it is called as a plot set. I'll show you that. Help plot set. So plot set means X will be this, Y will be this. There will be various arguments. You can say what is X label, what is Y label, what is this, etc. Right? Many things you can actually define over here. Okay, so that's the plot set, right? So let's try to define that itself now. Anyway, we had not used this. That's why I just want to show you how this works. So I'm using a different approach now. Okay, so plot set. What are the variables you pass? What is your x-axis is the time. What is the y-axis is s. Anyway, I want to plot this. That's all. But you see, I also add the x label, y label, etc. in a single command itself. Okay, so you specify x label, right? Comma specify what x label you want to give. It's a yearly data, so I will plot year. Okay, that's the x label. Then specify whatever you want to tell next. That's the y label. So y label. So tell what y label you want. Y label will be the stock price. Okay, so it's a stock price. After y label, I want to say what is the title of this whole figure, right? So that will be figure title. That will be stocks, maybe. Okay, then I want to say what are the various plot sets you are going to use. That will be m different values, okay, 1 to m. So plot set, there are 1 starting from 1 all the way till m. Okay, then I want to say what is the legend. Okay, they will come from the symbols. Each symbol, what is that you need to specify. That's why I'll write symbol. So that is a plot set. Okay, now I can actually define uh, what are the values of the ticks you want to check on the x and y axis. Okay, so tick values like uh, the x-axis could be years, y-axis could be maybe, right? Maybe the y-axis could be something different. All right. So that we will try to plot now. Okay. So that means whenever I want to do that, let me go to the next line. And so these are the format of sticks. First, let me define the y tick. So yt is equal to get the, you see the current axis GCA is the one which we have used, right? Recall from the fundamentals of MATLAB where we discussed about the various properties of a graph or various properties of a figure. Okay, so GCA, that's the current axis it's going to take, get current axis, and I'll have to specify which tick you want, that is y tick. Okay, so that gets this. Then what is a label I want to specify? So I'll call it as YTL, Y tick label, right? Label will be, it actually, I'll try to save it in the format of a cell. So cell is a function, create a cell of one row, and the how many cells you want, it is equal to length of the YT. Wherever you have a YT, you will have a ytick label as well. Okay, length of yt. Okay, now for every value I need to create this, right? How many values I have? Length of yt. So what, that's the length. So I'll go for a for loop. So for, say, k is equal to, starting from 1 all the way till the length of yt. Do something. What I want to do, I want to put the value into the yt label. Okay, so that is yt label. It is a cell, so you use the flower brackets to access that. Ytl of k is equal to, I'm going to write a text over there. So whenever you want to write a text over there, it is s printf. Okay, it's a s printf, right? Give I can see that there are the name could be 10,000, 20,000, like that. So at least 5 digits I need. Okay, so what I do, it is percentage 5.0f floating value. Okay, that's the space, that's the format in which you want to write, comma, what you will write, yt of k. Okay, so that is done. This is repeated starting from 1 till the length of yt, so that means it is end. So that is done. Now I'll write, say, this. I'll set this value. So get is the reading value, set is the value using which you can set them, right? Set, go to the current axis, that is GCA, get the current axis, comma, set your y tick label, right? Y tick label, I should use this. So that is y, it's a y tick label, and tell what you want. That is YTL. Oh, I think I wrote Y capital, Y small, right? Okay, YTL. Now you see, whatever we specified will come on the graph. All right. Anyway, the S and T are already present, right? Just let me save this and let me just check whether I can call this directly. So I will call plot stocks of, I'll just pass a T comma S, because even if you don't have a symbol, uh, I think it should work, but I'll make the symbols as null. Let me check whether this is going to work. Yeah, it's coming. Good. Not visible. Just hold on. I'll change this. Let's see that it is coming. Not coming. I'll run once again. Maybe that will. Okay. Same command. You can see, right? Now you see the axis has the specific values. One second, I think the x value is not visible to you. Just right now, can you see the horizontal axis is year because we specified that you are going to put the years over there. And even the y-axis values you can see, right? It is according to the stock value that is present of that specific stock, right? If I generally say write 10, 20, 30, 40, right? That's not appropriate for a stock value which is actually beginning from 10,000, correct? So because of that reason, I should see what is the stock value, then I should generate that. That's the point, right? So that's why I wrote a separate code, right, to do this. You can see the code over there, right? So which is nothing but I'm actually looking at that. So see the y label. So yt will be get current axis and the y tick value at those tick locations. Tick locations are wherever you have 10,000, 15,000, that dash marks. What you are going to put? You are going to put the yt of k. Yt of k is what? Yt of k will be the value of the stock. Okay, will be put up at those locations. So we could plot this. Now the benefit of this kind of uh, programming is that it will check what is the stock price internally and set the adjustments. The y values will be automatically set according to the price. So if your stock is varying only between say 10,000 to 20,000, you will see the ticks accordingly. So minimum value will be 10,000. The highest tick will be like uh, 20,000. In between you have 12, 14, 16, etc. coming into picture. Okay, so that's how the stock data will be that's the usage of this particular plot.